Hi, we are Group 7 and our project aims to correlate Energy Star scores of buildings to buildings features in order to predict GHG emission in the state of New York. For the purpose of this presentation, we'll go through the background and problem statement, our objectives and methods to achieve them. Then we will present our datasets and early works. Finally, we'll wrap up our presentation with the remaining steps to complete our project. First of all, to keep in mind that in the US, commercial buildings represent 45% of the total GHG emissions in large cities. The Energy Star score was introduced in 1992 by the US Environmental Protection Agency. It is a 1 to 100 score rating the energy efficiency of buildings, mainly focused around the energy use intensity. So far, the implementation of the Energy Star score program helped saving 5 trillion kilowatt-hour of electricity, avoid more than $500 billion of energy costs, and achieve 4 billion metric tons of GHG reduction.
Given this information, given the inefficient energy consumption and high GHG emissions in buildings result in 12.5% of US GHG emissions, and given climate change and the lack of energy resources, it has become critical to control GHG emissions. This is why our project focuses on how to help owners and property managers to better consume and reduce GHG emissions through the study of the Energy Star score calculation.
Our objectives in this project are first, finding correlation between the energy resource score and building attributes. Then discovering the weights of attributes which have a significant correlation with the energy resource score using a regression model. Then classifying buildings according to 3 to 5 attributes that have a significant correlation with the energy resource score. Finally, predicting GHG emissions for each group of the buildings. For our first objective, we want to get insights into the relationship between the energy resource score and other building attributes. At the first stage, we are going to find a correlation between several attributes that we have. While the majority of attributes are numerical, some of them are categorical, such as building type. We are going to assign a numerical value to the categorical attributes and find the correlation using the Pearson method. Then from the results derived from finding correlation, we can find dependent attributes and decide if any has to be removed.
To discover the weight of the attributes, multiple linear regression MLR can be used for predicting a continuous target variable, in this case energy star score, based on several predictor variables. Then we may assess its performance using a variety of measures including mean square error and R-squared score. These indicators provide the ability to assess the model's predictive power and evaluate the effectiveness of various regression procedures. Third objective, in order to classify the buildings, we will first select 3 to 5 attributes that have the most important impact on the energy star score. We will try 3 supervised algorithm methods: decision tree, naive Bayes, and KNN neighbors. Then we determine the most accurate method. Fourth objective is predicting GHG emission for each group of building. First, we use MLR for this objective, then we evaluate performance of regression to see its performance, and in case the performance is not accurate enough, we apply feature selection method to reduce the number of features in our simulation. Then we can use the model for decision making.
A dataset from NYC Open Data related to New York State containing approximately 28,000 data points and 250 attributes. After examining the dataset, we found that around 7,000 data points were invalid and we only needed 21 of the attributes. The first step in processing the data was to clean it, and we used Python as a tool for this purpose. After cleaning, we obtained around 11,000 data points. For numerical value, we filled missing value with the mean, while for nominal value, we used the mode. Next, we generate a correlation matrix for the numerical value and visualize the entire data set. Based on the correlation matrix, we were able to identify dependent and independent attributes. During the data visualization step, we noticed that 2 key attributes are a GHG emission and energy star score. We also plot for major attributes that were colored by building type. This helped us to understand the relationship between those attributes.
Remaining works for this project is utilizing the recommended techniques for each specified objective, conducting an assessment of each technique to determine its level of accuracy, retrieving and scrutinizing the resultant data, and finally offering recommendation based on our findings from data analysis.